Debugging is the activity of finding and fixing errors in a system, both in hardware and in software. Performance problems are considered bugs, so debugging can also include performance tuning, which seeks to improve performance by removing processing bottlenecks. The first section, failure analysis. If a process fails, most operating systems write the error information to a log file to alert system operators or users that the problem occurred. The operating system can also take a call dump, a capture of the memory of the process, and store it in a file for later analysis. Memory was referred to as the call in the early days of computing. Running programs and call dumps can be probed by a debugger, which allows a programmer to explore the code and the memory of a process. Debugging user-level process code is challenging. Operating system kernel debugging is even more complex because of the size and the complexity of the kernel, its control of the hardware, and the lack of user-level debugging tools. A failure in the kernel is called crash. When a crash occurs, error information is saved to a log file, and the memory state is saved to a crash dump. Every operating system debugging and process debugging frequently use different tools and techniques due to the very different nature of these two tasks. Consider that a kernel failure in the file system code would make it risky for the kernel to try to save its state to a file on the file system before rebooting. A common technique is to save the kernel's memory state to a section of disk set aside for this purpose that contains no file system. If the kernel detects an recoverable error, it writes the entire contents of memory, or at least the kernel-owned parts of the system memory, to the disk area. When the system reboots, a process runs to gather the data from the area and write it to the crash dump file with a file system for analysis. Obviously, such strategies would be unnecessary for debugging ordinary user-level processes. Performance tuning. We mentioned earlier that performance tuning seeks to improve performance by removing processing bottlenecks. To identify bottlenecks, we must be able to monitor system performance. Thus, the operating system must have some means of computing and displaying measures of system behavior. In a number of systems, the operating system does this by producing trace listing of system behavior. All interesting events are logged with their time and important parameters and are written to a file. Later, an analysis program can process the log file to determine system performance and to identify bottlenecks and inefficiencies. These same traces can be run as input for a simulation of a suggested improved system. Traces also can help people to find errors in operating system behavior. Another approach to performance tuning uses single-purpose interactive tools that allow users and administrators to question the state of various system components to look for bottlenecks. The Windows Task Manager is a similar tool for Windows system. The task manager includes information for current applications as well as processors, CPU, and memory usage, and networking statistics. A